Okay, hey, this is let f be a differentiable function such that they give you a ton of information here. So f prime, sorry, f of 1 is 5. So that means we know this red line here, this red information is that 1 comma 5 is on f, okay? This one I'm going to skip. They also tell you that f of 2 is -3. Turns out this is useless information. We know that f prime of 1 is 4. So that means that I know that the slope here is a slope of 4. I know that f prime of 2 is 5. Is 2. Again, that's also useless information, so I'm going to skip that. Now it also goes and it tells us that the function g is differentiable and g and f are inverses, okay? And then it asks then, what's the value of g prime of 5, okay? Now, the reason why the reason why I chose to focus on this 5 rather than this -3 here, right? Because look, they told me f of 1 is 5, and they told me f of 2 is -3. But I chose to focus on this one because they're telling me that g prime of 5 is what I'm looking for, okay? So notice this pink line. This pink line, I've noticed that they're inverses. Because it says that they're inverses, that means that if x value 1, y value 5 is on f, then x value 5, 5, 1 is on g. So 1, 5 is on f, and 5, 1 is on g. And not only that, I know that the relationship between the slopes of inverse functions is reciprocal, okay? They are reciprocal. The relationship between slopes of inverse functions are reciprocals at their corresponding points, right? And so at their respective points. So for example, we know that inverse functions have a relationship of if 1, 5 is on one function, then 5, 1 is on the other. And not only that, if the slope of this one is 4, then the slope of that one is 1/4. And so based on all of that information, we can deduce, without really doing anything, that the slope, or g prime, at 5 is the reciprocal of the slope of f at 1, okay, because 5 corresponds to 1. And so therefore they tell us the slope is 4. Therefore I know that my slope here now is 1/4. All right. That was more of a graphical and sort of an analogy, a graphical way of looking at the geometric and way of looking at that, rather than just plugging numbers into the formula that you would see solutions like that in the textbook. I decided to take a little bit of a different approach for this one.